So we're going to look at our next example, and it's going to be extension of the ones we had in the previous video. So let's suppose now, remember that we're forming a 5-team group out of 12 people. Suppose 2 members of the group don't get along and refuse to work together on a team. How many 5-person teams can be formed? So we're going to label these 2 people that can't work together, person C and person D. And apparently there's maybe bad blood between them and they just don't get along and they don't want to be on a team together. So let's think about all the ways that we could, so maybe I'll make a circle here, all possible teams. So you could select one of them and not the other. So it could contain C, but not D. Contain D, but not C. And the other way you could form a team is you contain neither one of them. Contains neither C nor D. So either you select one of them, one of the 2 and not the other, or you select none of them. So let's start counting these different ways. So let's start with this first one. So I have my team of 5 people, and I've selected C to be one of those 5 people. Again, order doesn't matter here, so you can put C anywhere else. So now how many people are left for me to choose? Well, C is gone, and I can't choose D now. So there's 10 people left, and there are 4 positions for me to fill. So this would be 10 factorial over 4 factorial times 10 minus 4 factorial. 10 factorial over 4 factorial times 6 factorial. And 10, 9, 8, 7, 6. Okay, so I cancel the 6 factorials. This 4 and this 2 will cancel with the 8. This 3 will go into their 3. So then this is the same thing as 10 times 3 times 7, or 210. So there are 210 ways. And for the same exact reason, there's going to be 210 ways for a committee to contain D but not C. Now we need to count that it contain the ways that we can make a team that contains neither C nor D. So if I'm looking here, I've got 5 spots, but they can contain neither C nor D. So now there's only 10 people, and I've got to choose 5 positions. 10 factorial over 5 factorial times 5 factorial, which I think we counted previously. It's 252. So then there's 252 ways for me to form a team that contains neither C nor D. And now these 3 groups, these are distinct events. They don't have any overlap. And so we can use the addition rule here again. Add up the 3 possibilities. There's 210 ways, 210, and then the last one, 252. It's us 672 possible ways. Now this isn't the only way you can do this problem, so I'll tell you there is an alternative method. There's a different way you can count this. You can use the difference rule. So the number of teams that don't contain both C and D, it's equal to the number, number of total teams of 5 minus the number of teams that contain both C and D. Well, if I'm looking at the total number of teams of 5, there's 12, choose 5. If they must contain C and D, well then 2 of the slots have been taken up, so it's 10, choose 3. So this would be, we found these earlier, 792, 10, choose 3, we found earlier to be 120, 672. So, and that's the exact same answer we got before. So here you could either use the addition rule or the difference rule. It's up to you.